Okay, hello class. This is going to be your first recitation video for this week, and I'm going to go over some unit conversions, and then we're going to go over adding up vector components into the length of the vector, finding the angle, and things like that. I'll continue to explain as I go on. So first, I want to do the units. So what we're going to be doing is we're going to be taking a certain speed in miles per hour, and we're going to be converting it to meters per second. Okay, so say we have a car, and we're just going to draw the car real quick. Excuse my drawing. But so this car is going to go 60 miles an hour because it's on the highway, and we want to get meters per second. So first thing we have to do is we'll put 60 here. This is miles per hour, and we want to convert miles to meters. So there's 1,609 meters in a mile. So we'll do that first. So we want to put 1 mile on the bottom because this is our conversion factor here. So we'll put 1 mile, and on top we have 1,609 meters. So then what we're going to do next is we also want to get rid of hours. So we're going to have hours on the top, and then we're going to have seconds on the bottom. And so then there's going to be 3,600 seconds in an hour. So then you just have to carry out this this calculation here. So very quickly, 60 divided by 3,600 is going to be 1 over 60. But for the other calculation, I'm going to pull up Wolfram. And this is seeming a little blurry. Maybe that'll be better. Okay, so Wolfram alpha, and we have 1,609 divided by 60. Okay, yeah, that makes sense. All right, and so then this will give you 26.8, 166 repeating, 166 repeating, and that will be in meters per second. I paused there for a second because I was looking at the answer and I was thinking, does this make sense? Now, this is something that all of you guys should be asking yourselves whenever you're solving a problem. Does my answer make sense? Like physically, just like think about it for a second. Because if you get a problem where your answer is 20 meters per second, but you're only working with like you're pushing a box across the floor, then that should mean that there's something off with your calculation. So does it make physical sense is a big question you guys want to ask yourself while you're doing this. Another thing that you'll learn in physics is we will be talking a lot about problem solving. So decomposing word problems will be a big deal in this class, and we'll try to make sure that everybody understands how to do that. Okay, next I want to go over scalars and vectors, and the only scalar to have a magnitude and a direction is going to be distance. Vectors, on the other hand, have both a magnitude and a direction. Okay, so the next thing I want to talk about is unit vectors. So if we have a coordinate axis here with our y and x axes, a unit vector in the y or x direction is going to be pointing directly in that direction of the axes and is going to have a value of 1. So we have 1 and 1 here. And so this is going to be an x hat, and this is going to be a y hat unit vector. And we'll talk about a little bit later how unit vectors will cancel when you take dot and cross products and that kind of stuff. And so how you can make problems a little bit easier. When you're talking about vector notation, it's going to be slightly different. When you're talking about vectors, you'll have, say, a vector A, or capital A, and we always put hats over our vectors, or not hats, but arrows. And so they're going to have, say, this is A, B, and C are going to be coefficients, so they're just going to be constant numbers. And then you'll have, instead of x hat, they'll be denoted as I hat plus another coefficient, and then you'll have j hat, and then you'll have plus another coefficient, and then k hat. So that's how we identify which, so this will be x, this will be y, and this will be z. They're equivalent to each other. It's just another form of notation. X, y, and z hats. I'm trying to make it so it's clearest picture possible. I know that this side of the board is going to be blurrier than this side, so I'll try to keep most of my work over here. And you guys can watch these videos back. If anything's unclear, I'll say everything that I'm writing on the board so that you guys don't miss anything. Okay, next up we're going to be talking about how to use the Pythagorean theorem in order to, sorry, my camera's not focusing. Yes. Okay. We're going to be using the Pythagorean theorem in order to put together components of vectors in order to get a resulting vector. So say we have this girl named Sally, and she's at our center of our coordinate axes here, right? And say Sally decides to walk, I don't know, let's say 6 kilometers in this direction. And then once she's done walking 6 kilometers east or in the positive x direction, whichever one you guys want to use, and then she decides to walk 9 kilometers in the north direction, or the positive y hat direction. What we're going to do is we'll use Pythagorean theorem, and here's your formula here. It's going to be, I don't know, we can use distance or displacement, d. D is going to be equal to 6 kilometers squared plus 9 kilometers squared. And from there, what we can do, let's see if that makes it any better. We'll do the addition here. And so this is going to be 36 kilometers squared plus 81 kilometers squared. And then this is still going to be underneath the square root. And so now we're going to add these two up. And so this is going to be 7 plus 110, so 117. So square root of 117 kilometers squared. And now since we have this all added up, we can actually treat the units as like a quantity, right? So if we were to factor out 1 kilometer squared here, we could do it like this, and we would have 117 times 1 kilometer squared. And so then we can take the square root of kilometers squared, which is just kilometers here. So this is going to be the square root of 117 kilometers, and that'd be the length of our vector, would be 117. So from there, what we can do is you can either give a decimal answer, and you could round with sig figs, but this is our exact answer right here. It's the square root of 117. This is going to come out to be like 10.9, 10.8, right around there. So if we put that into Wolfram, we'll get our exact answer. Okay, so I've done the calculation here, and this is going to be 10.817 kilometers. Okay, so the next question that's going to be asked from this is what if you were to take a line and you were going to connect your starting position and Sally's ending position, what would the angle be, or the compass direction would be from east or north, whatever the question would decide to ask you. And for this, we can use some of our trigonometric identities to solve this problem. So I'm going to write these in up here. So we have SOHCAHTOA. This is the acronyms, or like the memory device in order to remember your trigonometric identities. And so says that sine of theta is equal to opposite over hypotenuse. Cosine of theta, or co says that this is supposed to be an A, so SOHCAHTOA. Adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. So in this case, we have the length of our adjacent and our opposite here. So most of the time you're going to want to use the tangent function for this, because if you have the components of the vectors. So in order to do this, we're going to take the inverse tangent of both sides, which is going to leave us with just the theta on this side, and we'll have an inverse tangent of opposite over adjacent, which in most cases is going to be y over x. So then we'll take this, and this is going to be y over x, and so then we can finish this out, and so this is going to be 9 over 6, and there's technically kilometers in here, but those cancel because we're dividing, and so then we just need to take the tangent of 9 over 6, and going to Wolfram to do that because that's my calculator. And so in degrees, oh, I gotta do inverse tangent. It's easiest to do just say arctan, and that'll give us, converting from radians to degrees, that will give us that theta is equal to 56.31 degrees. And that's how you would solve one of these problems. Okay, so next thing that we're going to go over is we're going over how to add and subtract two vectors. So first thing, we'll just give ourselves two vectors. I'm just going to make them up. And so we're going to have A is going to be equal to, I don't know, 13.7, and this will be X for X hat plus 17.6 Y hat, and then we'll do the same with the second vector B, and we'll say that this is, I don't know, 6.7x, and this will be 13.4. So this is twice as much. I don't know. Just making up vectors. So if we're adding two vectors and we're just trying to add up their components, all we have to do is we have to use the Pythagorean theorem, but we're going to expand each part. So what we'll do here is we'll say that all right, so a plus b, and we're just trying to find the magnitude. That's what the absolute value signs here. They just mean we're finding magnitude. So we're going to take the square root, and I'm making this a little bit longer so I have space to write this stuff. And so in the first boxes, or in the first parentheses, we're going to put our x components, and then in the second one we're going to put our y components. So if this was, say this say this was a subtraction sign. This plus sign here in the center would still be the same, but for the sign in between the two, it's going to be a minus sign. So let's see what that looks like, and then we'll change it to a plus sign afterwards to carry out this. So we're going to put AX here, so that'll be 13.7, and then we'll have plus and then 6.7 in this box. So we have AX, minus BX, and then same thing on the other side. We're going to do 17.6, then it would be minus 13.4. And so now we can, this is going to be the same thing over here. We're going to be AY minus BY. And so this would be if we had a minus sign here, so, but we're not going to do that. I just wanted to show you that's what you would do if you had a minus sign there. So we're going to change these to pluses. So that's how you set up this problem. And so what we're going to do now is we'll simplify this down. So this is, there's a 4 here, and we're going to carry the 1. So this is going to be 20.4 plus, and then we'll do this addition here. There's going to be a 0 at the end. And then we have to carry the 1, so this is going to be 131. And so this is still underneath a square root, which can also be written as the entire quantity raised to 1/2, because that's technically what you're doing with a square root. All right, so now I'm going to chuck both these quantities into Wolfram, and I'll see what we get back here. So for 20.4 squared, we get 416.16. And then for 31 squared, I'm feeling it's like a little bit over 900. Yeah, 961. And then this is still underneath the square root. So let me just add these two together and take the square root. So 416.16. And then the real problem with this is I wanted to take the square root. So this square root is going to be equal to 37.11. And that's going to be the length of our vector here. And now notice I haven't assigned any units to anything, so I'm not keeping track of any of that. But like say these guys were in meters, then this guy would be in meters too. So now we're probably going to be asked next to find the angle in degree, like what's the angle of this vector from the origin. So what you're going to want to do is we're going to use our tangent formula, but like I showed you earlier how the signs are supposed to go, we're going to have that theta is equal to inverse tangent of AY plus BY all over AX plus BX. And that's really why I tried to use the minus sign earlier, because so if this was A minus B, then we would have AY minus BY and AX minus BX here. And so then we can go ahead and put this bad boy into Wolfram or your calculator, artan. And so we've already done the operation of adding these two vectors together here, and we did it right here. So these numbers here, 20.4 and 31, are going to be our numbers. So we can plug 31 as our y and 24 point, or yeah, 20.4 as our x, and then that will give us our result in radians, and then that will also give us, we can also convert that to degrees, and what your calculators will do it for you automatically if you're still in degrees, and so that'll give you 56.65 as the resulting vector when you add the two. Okay, last thing for this problem is I want to clarify that, so say you have some extra extra operation going on. So like say we had 5a, gotta be capitalized, plus 3b. So what you would do is you would insert a 5 next to the a components underneath the Pythagorean theorem, and a 3 underneath or next to the b components in this Pythagorean theorem here. So you just take this 5, sneak her in here, and sneak her in here, and then the b, you'll sneak the 3 in there, and you'll sneak the b in front of those. So you just need to multiply those underneath the square root and inside the parentheses. And that's how you would handle the larger addition of a couple vectors. Okay, so next up we're going to be taking a couple vectors, and we're going to be given their lengths, and then we're going to add them up. So we'll have this vector here, we'll have this vector here, and so we'll have this this vector here. This will be called A, and we'll call this one B, just for simplicity. And I'm going to change markers here. So when we're adding vectors up, the resulting vector is going to look a little bit like this. So what we're going to do is we're going to use the tit to tail method. So whatever vector you're adding first, so say if we're doing A plus B, then this vector here, let me get a different color here, make this obvious. So we'll have this resulting vector here. This will be A plus B. So we're going to be given a couple magnitudes and some angles. So this will be theta, and we'll call this angle phi, just to differentiate between the two. So now what we're going to do is we're going to say, all right, well, we're going to give you guys that A is going to be, say, I don't know, let's do 44 meters, and that theta is going to be equal to 33 degrees, and that B is going to be, let's say, I don't know, let's do 32 meters, and that phi from the negative x-axis is going to be, let's say phi is going to be, I don't know, 56 degrees. Okay, so now to solve this problem that we have going here, we're going to break down each of these vectors into their components, add their components up, use the Pythagorean theorem to re-add the components, and then we'll use the inverse tangent to the inverse tangent function to retrieve our final angle with respect to the x-axis. Okay, so next up, so what we're going to do is we're going to take our trig identities, so we're going to list them off here. We're going to have SOHCAHTOA, and so we're going to look at these and we're going to say, all right, well, sine of theta is going to be equal to opposite over hypotenuse, which in this case, our opposite would be the component vector here, or the components here, and this will be in the y direction, right? So this is going to be the opposite, so that's going to equal y. So we're going to have y, we're going to have this is going to equal y over r, and we'll use r as the length of our vectors in this case. So then we can just, I don't know, solve for y. So what we're going to do is we're going to take y equals r sine theta, so we're just moving the r to the other side of the equation. And then we can do the same thing with cosine, but the a in this case is going to be our x component of our vector, or this guy here. And so we can say that x is equal to r cosine theta, and we're doing the exact same process as before, right? So we're just taking our cosine like we would here. This would be adjacent. The hypotenuse would be the same. So when we change these over to the components of our vectors, this would be the x component. This would be r again. We're multiplying r to the other side. This would be a cosine theta. And that's how we're going to get these two formulas here. Okay, so now all we have to really do is some plugging and chugging here, and we'll get to a place where we can see what we're doing. So let's take these. So this will be 44 times sine of theta, where theta in this case is going to be 33. And so, and then same thing down here. I'll do this. I'll map both these out first. So 44 cosine of 33. Okay. So go to Wolfram, get our 44 times sine of 33, and that gives us equal to 23, so 23.96. Okay, so now all we have to do is, in our calculators, we just change the sine to a cosine, and that will give us a 36.90. Usually I just cut my decimals off after the 100th place for this branch of physics anyway. So now we have the x and y components of A, and now we can do the same thing for B. So for B, I'll use a different color, and it looks like red is the other color that really looks like it works well. So we can say, oh, one thing before we do that is now we should get proper notation for this. So we'll say that this is AY and this is AX. So now for BY and BX, we can do the same thing. We'll be using same trigonomic identities. The y will give you the same, or the phi will give you the same type of identities here, because we're measuring it from the negative x-axis. So we know now that our x component has to be negative. So we can use the same process, and we'll get to the same place. But at the end, we have to make our our bx negative. So we'll just add a negative sign there to keep track of that. Okay, so we'll go r sine theta, and this is r cosine theta. Actually, this is supposed to be a phi. Sine phi and cosine phi, and then we get our equal signs out, and we'll do this. We'll write it out like we did before. So this is going to be 32 sine of 56, cosine of 56, equal signs, and now we're ready to plug it into our calculators here. Again, sine 56, cosine 56, just in case anybody was missing that. Okay, so I'll change this to a 32, and we'll change this to a 56. And so that'll give us, for our bx component, we'll say that this is negative 17.89. Now I just have to change that to a sign to get the other one. And that'll be 26.53. And now that we have all of our quantities here in our components, and we have our negative signs out, we have to remember that these are all in meters. Okay, so now we can start to add up our components. So the resulting component of this vector here is going, or the result of this will be, so we'll add up our y components, and so we'll do that here. So I'll just draw some pretty lines here, and I'm adding these together. So 2396 plus 2653, that's going to be 50, and then we're going to have a 9 out here, and then we're going to have a 4 in here. And then for this bottom part, we have to actually subtract these because we have a negative sign in here. So what we're going to do is, this will be, if we subtract these two together, we'll get a 0.1 for the decimal places, and then we'll get a 19 here. Make that better. We'll get a 19 here. So now these are our two components of our resulting vector. These are in meters. So now what we want to do is we want to take Pythagorean theorem, and we'll call the length of this vector a plus b. I mean, that's what we'll name it. We'll name it c. And so this is the magnitude here of c. And so we take our square root out, and this will give us, and now in this case it doesn't matter, since we've already added up our vectors down here, it doesn't matter which way we put them. So we'll get 50.49 here, and 19.01 here. So then let's plug them in. Okay, so 50.49 squared and 19.01 squared. Okay, so the resulting vector here is going to end up being, and I took this, I went ahead and plugged this all into Wolfram, this entire formula, so no simplifying here. We're not gonna, this is just the end of the question. So this is going to be 53.95 meters. And so that is the result of our vector here. And now, since we've already got these two guys in components here, we can just take our theta function here for inverse tangent. And so then we'll say that, so this is our y component, so we'll have 50.49 meters over 19.01 meters. And so then you just need to plug that into your calculator here, and that will give you okay, that'll give you 69.37. Nice. And that'll be in degrees. And so now this problem has been solved. Again, this is 69.37. I'll write it down here so it's more, or it's easier to see. So to recap, we have our vectors here. We took our trig identities. We solved our trig identities. Here, we kept track of our negative sign at the bottom here. We carried out some calculations to get our vector components. We added our components together based on whether they were a y or a b, or a y or an x. And then we went up here and did the Pythagorean theorem, and we found the resulting length of the vector a plus b, which we named c. And then we took the inverse tangent function, and we took our x and our y components of a resulting vector. We plugged them in here, and we got the angle that our vector lies from. And so now this angle theta would be this guy here. So and if you wanted to take that and you wanted to say, all right, well, what's it from the y axis? We don't want the x axis, we want the y axis. All you would do is you would take 90 minus theta, and then that would give you your answer. So in this case, this would be 21? No, it would be 20.63, and so that would be from y-axis. Actually, this should be flipped, because if you're measuring it from the y-axis, you always measure counterclockwise, and so this would actually be theta minus 90 in this case, and this would be negative, because this angle here, if you're doing absolute value, it doesn't matter. Okay, so next thing on our agenda is to talk about dot products. So we're going to have our two vectors again, a plus b. You're probably sick and tired of seeing them, but here they are. And so the dot product of these two vectors is going to look like ax bx plus this is going to be ay, and this is going to be by plus az bz. Okay, so say for a given vector, we'll take, or two given vectors, we'll give a as 3, 4, 5, and we'll have b as let's do 6, 7, and 8 as our components. So this is going to be our x component, our y component, and our z component, if you're looking at it like a column. So all we have to do in this case is we just have to start plugging and chugging. So we have ax, which is going to be 3, and this is going to be times bx, which is 6, plus ay, which is 4, times by, which is going to be 7, and then we're going to have plus az, which is 5, and then bz, which is going to be equal to 8. So let's just do this real quick. This is going to be 18, this is going to be 28, this is going to be 40, and then you just have to add these up. That's going to be 68. 68 plus 18 is going to be 86. And so then this is the result of the dot product. So dot product takes two vectors and dots them. It's a form of multiplication, I guess, and it'll give you a resulting scalar at the end. Okay, so let's go back to our two vectors. We have A was equal to 3, 4, 5, and B was equal to 6, 7, 8. And so now what if we want to know the angle between these two? So the dot product has another definition. So if you have the magnitude already of each vector, what you can do is you can say, well, all right, you can say that this is true. So AB cosine theta. And so that's going to be equal to our original formula, AX BX, and then AY BY plus AZ BZ. I know it's getting hard to focus at the end there, but this is AZ times BZ over here. So all we have to do now in order to find the angle in between these two vectors, or theta, what we can do is we can just divide to the other side A times B. And so this is the magnitude of A and B. So all we have to do is find that magnitude, and then, or those magnitudes, and then divide them to the overside and take the inverse cosine of both sides. And I'll show you guys how that works. So we already know that this entire side, this is equal to 86, because we just did that. So next up, all we have to do is we have to find A and B. So then A is going to be equal to square root of 3 squared plus 4 squared plus 5 squared. Okay, so 3 squared is 9, plus 4 squared is going to be 16, which is going to be 25, plus 25 is going to be the square root of 50. And so B is, we follow the same process, and this is going to be 6 squared plus 7 squared plus 8 squared. And so this is going to be 36 plus 49 plus 64. 64 plus 36 is going to be 100, plus 49 is going to be 149. And so let's find those two square roots real quick. The one should be a little bit above 7, and the other one, I'm not too sure of the top of my head. Should be a little bit bigger than 12. Okay, so square root of 50 is going to be 7.07. And then the square root of 149 should be 12.2. Okay, so now we just have to multiply those together. Give me one moment to do that, and so we have 7.07, and so this will give us that'll actually give us 86.32. It seems like I've made a poor choice in vectors, as you can see up here. 3 and 6 are just multiples of each other in the x coordinate, so it's just basically doubled it. I've done the same thing with 4 and 7 basically, and 5 and 8 are also very close to each other. So, but we're going to keep on keeping on here. So then we have 86.32 times cosine theta is equal to 86. And so we divide both sides by 86 and take the inverse cosine. So then we have theta is equal to inverse cosine of 86 over 86.32. And so then we just need to throw that in our calculators. And so then theta between these two is going to be 4.935 degrees. So yeah, it's not that big, but as you can see, that 0.32 actually did make a difference in this case. Okay, so we were just talking about dot products, and so realistically, what a dot product measures is how parallel two vectors are, while a cross product is determining to what extent the vectors are perpendicular to each other. So we have this thing in physics called the right hand rule. So you take your hand like this, your right hand. I know it probably looks like my left to you guys, but it's my right. So when you have two vectors here, my two fingers, whenever you cross them and they're perpendicular to each other, the resulting vector is the thumb. Never use your left hand, always use your right hand. Because if you use your left hand, you'll get it backwards. So when we're talking about vector components, specifically unit vectors, we have our I, J, and K unit vectors, right? Well, let's just extend this to an I. This is just an extra I we're putting here, but I'm explaining this rule to you. So whenever you cross I with J, you'll get K. And now if it goes forward in this sequence, I, J, and you get K, then the resulting cross product will be positive. Now let's just say over here that there is just an imaginary K there. So now if we cross I and J, or J and I, we're going to get K. So if the order is backwards, then this resulting unit vector is going to be negative. This is going to be positive. So with that being said, we can do all of the cross products of the unit vectors. So like we did earlier, I cross J is going to be equal to K. And then we did J and I, and that's negative K. So then next up, we can do J and K. So J cross K is going to be I. So we have J to K, and then it goes forward in the sequence. And so that gives us a positive one. And so then we can also do, we already did J and I. And then, so let's do, how about this? Let's do I and K. So if we do K cross I, we will get J. And if we do I cross k, we'll get negative j. And so last one up should be, we did that. Should be k cross j, and that'll give you a negative I. Okay. But we also have to note that if you ever cross a unit vector with itself, then it's going to be equal to 0. Because we're trying to say cross product is a measure of how perpendicular two vectors are to each other. So then in that case, they're parallel with each other because they're unit vectors. So then since they're parallel, then the cross product is equal to 0. So then I cross I equals 0, j cross j equals 0, and k cross k is equal to 0. So the formula for the cross product is then as follows. So then we have, so here's the actual formula: A cross B, and so say these all have A, Y, and Z components. So they're three-dimensional vectors. So then we have AZ I and plus, or no, this is AX I, AY J plus AZ K, and we are crossing this with BX I plus BYJ and BZK. And so now all we have to do is FOIL in order to get this formula. And there is a general formula, and we will arrive at it very soon. So we just need to FOIL all these terms and then use our cross product identities that we just had in order to find our general formula, because things will cancel. All right, so first things first, we have AX, BX, and then we have I crossed I. So then we can just say, well, screw this. This is equal to 0, since it's I cross I. So we have a 0 as our first term. And then AX and BY. And then that's I cross J. And so we saw that I cross J is equal to K hat. So we can just replace that with that. And then we have AX I times BZK. And so then that's going to be plus AX BZ, and then I cross K. I cross K is going to be negative J hat. So we'll leave that in parentheses there, and we'll get to it eventually. Okay, so next up we have to do the second one. So we have to FOIL out this term into these three terms. So then we have plus AY BX, and then that's J cross I. So then that's going to give us a negative K. So we have to have our negative K here. And then moving on, we're getting to the blurrier side of the board, so I'll move down one. And so then next up, we're going to have these two terms crossed together, and that's going to give us another 0 for our unit vector. So that's going to cancel that term out. So next up, we have AY BZ, and so that's going to be J crossed with K, which is going to give us I hat. And then we're done for our second one. I'll just add the plus 0 over here, just so we keep everything in line. And next we have plus AZ BX, That's k cross I, so that's going to give us j hat. And then az times by. And so then we have k cross j. And so then k cross j is going to give us negative I hat. And then we have az, bz, but that's k cross k, and that's going to give us plus 0. Okay. So now what we're going to do is we're going to group these terms by their unit vectors. So all the j's are going to go together, all the k's are going to go together, and all the i's are going to go together. So first up, our first I hat is right here. And so we'll go ay, bz, and we're going to factor out that I. And then our second one is here, and we're going to put it second because it's got a negative in there. And so we're going to have az, by, I hat. Next, we're going to group our j terms. And so we have our first j term here because it's positive. So we're going to have az, bx, and then we're going to have a negative, and then we're going to have ax, bz. And that's going to be j hat. And then last, we have our k hats. So our first one is going to be here. And so we're going to have ax, by, minus az, by. Wait, yeah. Give me 1 second. I want to check this. Okay, so I picked the wrong term. The last k hat is up here. So this is going to be ay, and this is going to be bx. I thought I saw something wrong. And so then there's our k hat. And so this is your general formula for your cross product between two three-dimensional vectors. And so this can easily be reduced. So say you guys didn't have any z components, you would do the same thing, but with just these two guys. So you can cut that off, and you'd say, all right, well, that first term is going to be equal to 0, and then the second term would be ax, by, k hat, and then you would just do the same thing, but at the same, oh, you wouldn't cut it off. Never mind. You would, these would be considered zeros here. So then you would go through, and every term that has a bz or an az would become 0. Okay. So that is how that is done. Okay, so in order to find the components of this vector, it's right here. This is going to be your x component, this is going to be your y component, and this is going to be your z component. So for a given vector, if you're given actual numbers for these quantities here, all you have to do is you have to plug in those quantities into this formula, and this formula here. And so this will be your, if we call this vector A cross B, let's call it V. And so then this would be VZ, this would be VX, and this would be VY. And so then all you need to do in order to find the magnitude of this vector is you just have to take, you could say V absolute value is equal to Pythagorean theorem. So Vx squared plus Vy squared plus Vz squared. And that's it. Okay, so that's all for this this lecture. This should give you enough information to go ahead and finish your unit vector assignment on Expert TA, and I look forward to seeing you guys on Tuesday.